All right, let's get right into it. We're on the internet all day, every day, right? But we almost never stop to think about the invisible magic that makes it all feel so fast, so instant. So today, we're going to pull back the curtain on one of the internet's biggest unsung heroes. We're talking about the Content Delivery Network, or CDN. Now, to really get what a CDN does, we first have to understand the huge problem it was built to solve. And here's the thing, it's not a software problem, it's a physics problem. It's about the simple, unavoidable fact of distance.
So let's make this super concrete. Let's ask a simple question. Say you've got a website, and its main server is humming away in a data center in Mumbai. Why on earth does that same website feel completely different and way, way slower for someone trying to use it in New York?
Well, just look at the journey that little piece of data has to take. A user in New York clicks a link. That request has to travel thousands and thousands of kilometers. We're talking across continents, through these massive undersea fiber optic cables, just to get to the server in Mumbai. And then, the server has to send its response all the way back along the same path. That's a round trip of something like 25,000 kilometers. Just incredible. And that massive journey? It comes with a price tag. I'm talking about latency. We're limited by the actual speed of light here, so that trip adds a penalty of about 300 milliseconds for one single request. And you might be thinking, 300 milliseconds, so what? Well, here's the thing. A modern website isn't just one request. It's dozens, sometimes hundreds of them. And all those little delays, they stack up fast. And all of a sudden, your instant website feels anything but. It feels slow, clunky, maybe even broken.
So, how in the world do you solve a problem that's literally baked into the laws of physics? Well, you don't break the law, you just find a clever way around it. You shorten the distance. And that, right there, is the beautifully simple idea behind the Content Delivery Network.
So, what is a CDN, really? Think of it like this. It's a massive worldwide network of smaller servers, all placed in strategic locations. We call these servers points of presence, or POPs for short. And their whole job, their entire reason for existing, is to act like little outposts for your website. They take your content from that one central spot and move it out to the edge of the network, way, way closer to where your users actually live.
Okay, so once a CDN is in the picture, the whole game changes. That user in New York makes a request. Does it go to Mumbai? Nope, not anymore. Instead, it gets intercepted by the closest POP, which might be right there in New York City or just a few miles away. The journey is now maybe a few hundred kilometers instead of tens of thousands. It's a total game changer.
Let's just put it side by side, because the difference is just staggering. Before, you had one lonely server, a gigantic round trip, and painfully slow load times. After the CDN, you've got hundreds of local servers, a tiny little hop for the data, and load times that are just blazing fast. The improvement is, well, it's not even a competition. But, just having a bunch of servers scattered around the globe isn't quite enough. The real magic, the secret sauce that powers the CDN's incredible speed, is a concept called caching. Honestly, a CDN without caching is pretty much useless.
So, how does this caching thing actually work? Let's walk through it. Imagine you're the very first person in a city, say London, to ask for a file from our website. The local POP server doesn't have it yet. That's what we call a cache miss. So it has to make that long trip to Mumbai just one time to get it. But, and this is the absolute key, it saves a copy for itself. So when the second, third, or 100th person in London asks for that exact same file, bam, it's a cache hit. The local POP just serves up its copy instantly. No round trip to Mumbai necessary. It's just incredibly efficient. And that brings us to this famous quote. It perfectly captures the biggest challenge with caching. I mean, it's great to have copies everywhere, but what happens when you update your website? How do you tell all those hundreds of servers around the world, hey, that copy you have is old now? That problem is called cache invalidation, and it is notoriously hard to get right. But, of course, modern web development has a really brilliant solution to this. Instead of just calling a file something like main.js, the tools we use today generate a unique name based on the actual content of the file. So you get these crazy names like you see here. Now, if you change even one single character in that code, the file name changes completely. To the CDN, this new file name looks like a brand new thing it's never seen before, which forces it to go get the latest version. It's a super clever trick that lets you tell the CDN to cache files forever while still knowing your users will always get your latest updates. Okay, so CDNs make things fast, we get it. But over the years, they have evolved into so much more. See, because they sit right in the middle between your users and your servers, they're in the perfect spot to offer a whole suite of other, well, superpowers. For starters, a CDN's massive network can just soak up these huge malicious traffic attacks, called DDoS attacks, that would normally crash your server. It can also act like a smart traffic cop, balancing all the incoming requests across your servers so none of them get overwhelmed. It can even handle all the complicated encryption stuff for secure connections right at the edge, which actually makes things faster for your users. It's like a shield and a traffic controller all in one.
But here's where things get really, really interesting. This is the next evolution. What if you could run your own code directly on that global network of CDN servers? Well, you can. That's the whole idea behind edge functions, and it's turning the CDN from a simple delivery pipe into a new kind of global computer. It's like you can hook into the journey of a request. You can run a piece of code to check if a user is logged in before anything else even happens. After a cache miss, you can actually change the request before it goes to your main server. Or you can grab the response from your server and transform it, modify it before it even gets cached. You are literally programming the network itself. And the things you can do with this are just incredibly powerful. You can block hackers right at the edge so they never get a chance to even touch your servers. You can run A/B tests by showing different users different versions of a page on the fly. You can even automatically optimize images, serving up next-gen formats to browsers that support them. And all of this happens with virtually zero latency. It's amazing.
So when you step back and look at the whole picture, you see this really remarkable transformation. The CDN started as just a simple tool to make websites faster. Now, it's become a foundational piece for building the entire next generation of applications.
This timeline really nails the whole story, doesn't it? Back in the 90s, it was a network that solved the physics problem of distance. In the 2000s, it grew into a platform that gave us security and reliability. And now, today, it's become a true global computer, a programmable environment that lets us run our code just milliseconds away from every single user on the planet. So, what's the big takeaway here? A CDN is not just about speed anymore. That's table stakes. It's a completely new kind of computing platform. It has fundamentally changed how we build for the web, and it leaves us with one really exciting question to chew on. Now that we have this invisible, global computer at our fingertips, what are we going to build with it next?